Yeah, I think maybe can you wait? No. Yeah. So good afternoon. This is the second session of NMRG. So no, yeah. So we said before in the first session, but we would like to remember you the note well about the intellectual property. So the IETF follows the IETF intellectual property rights disclosure. So just be aware of that and participate in the IETF. You agree to follow the IETF process and policies that apply for this meeting. Also, it's important to understand that the IETF makes recording of online and in-person meetings, so including audio, video, and photographs, and publishes those records online. So if you're not wearing a red lanyard, you're consenting to appear in such media. Also, if you participate online and turn on your camera or microphone, you consent to appear in such recordings. Also, it's important to acknowledge the privacy and code of conduct. So as a participant or attendee to any IETF activity, you acknowledge that written audio, video, and photograph records of meetings may be made public. So, and this will be rendered considering the IETF and IETF procedures. So also this applies to this meeting. Also, it's important to remember the goals of the IETF. So the IETF focuses on long-term research issues related to the internet. And this is in parallel with the IETF, which focus on shorter-term issues of engineering in standards making. So remembering the IETF, it's not a standards development organization. So our main focus is to publish information and experimental documents. Also, it's important for any doubts to refer to the RFC 7418. This is the useful links for this session. So for the materials, the Meet Echo. So also it's important to remember everybody to enter and use the Meet Echo on-site tool in order to sign the blue sheets. We also have the notes on the IETF website. And also we ask for anyone that is willing to help in these notes or to verify the information in these notes. It's also important. And also the available post-meeting, we will have the video recording of the sessions. So this is the agenda for this session. So at first we will have the presentations on network digital twins. After that, we will have some presentations on agentic AI and LLMs. And finally, we have other presentations finishing the session. And that's it. Yeah, so for the first presentation, we have the using network digital twin visualization for application traffic engineering from Felix. So Felix, do you hear us?
Yeah, I hear you. Do you hear me?
Yes, we can hear you.
Perfect. So
you just show the slide and then you can start.
all right. So thank you for inviting us to the NMRG. Today I'm presenting you the paper we submitted to the CNSM ENSO app workshop called Using Network Digital Twin Visualization for Application Traffic Engineering. I am presenting on behalf of the co-authors Leon Lux and Sebastian Rieger, which should be also here today. And if you want to take a look at our paper, you can scan the QR code on the slide. Yeah. So what was our motivation and starting point? We already had the DixieNet environment, which is a prototype for NDT experiments where real networks can abstracted to virtual network environments as multiple siblings that only mimic parts or in which individual characteristics of the network. So you have, for example, a sibling for performance evaluation and another one for like configuration evaluation. And this DixieNet environment already allows continuous data exchange and network modeling to address the NDT requirements that are stated in the IETF NMRG Network Digital Twin Architecture draft. And in this draft, it's also stated that the real-time visualization is also a key requirement for NDT systems. And it's kind of a symbiotic use case as application traffic engineering also needs a visualization to support operator cognition and awareness. So we needed to understand and improve application-driven network load without interruption of the production environment. And for that, we developed a multi-vendor fine-grained visualization with the ability to recall historical events for the use case of application traffic engineering. So as I said, we developed a application called DixieWiz, and its architecture is depicted in general on the right side. So it's a modular and extensible client-server architecture in which the back end is separated from the front end. And the backend is used to communicate with the Container Lab environment to pass the Container Lab YAML to get knowledge about the environment and also communicate with Container Lab through the CLI to get entire knowledge about the NDT environment. And the backend is also used to connect to the virtual network devices through GNMI to continuously poll the GNMI data. And we both support the get operation and subscribe operation. And we found it a sweet spot of 500 milliseconds between management traffic and CPU load versus granularity. So what we do here is poll the GNMI data and store it in a double-ended queue, which has a maximum length or storage capacity of 120 snapshots. And if we hit that limit, we discard the oldest value. So we have a constant time frame for historical a Wayback Machine of 60 seconds with in combination with the polling rate of 500 milliseconds. And yeah, that's it. We connected to the front end using controller logic and visualize the data in the front end and deploy some user interfaces in the front end that are both connected using a REST API and a WebSocket. So for static content, we use the REST endpoint, for example, to pass the topology graph definition. We use the REST endpoint as it's passed once at startup. But for the real-time updates, we use the WebSockets. So for the router data or for passing the available timestamps, we use the WebSockets as well as for the time machine state. So for our use case of traffic engineering visualization, we created an experiment. So we passed application traffic through a NDT topology. In this case, IPv3 traffic, and from the leftmost router to the rightmost router. So from the leftmost host to the rightmost host, from H3 to H1. and you see at a glance what is happening at the network, as you have link colorization, you have link width, and you, for example, see at a glance that host 2 isn't involved in the communication, and you see instantly what is happening in the network, and you can tell that we distribute the traffic. In this case, it's a policy-based routing distribution, but you can perform similar using segment routing or other multipath aware applications and transport services. And by that, you can visualize the behavior of different transport services or policies in the network digital twin. And around the force graph layout, you see a bandwidth overlay, and the bandwidth is calculated in real time from the interface octet counters also obtained via GNMI. And using those graphs, you can also obtain deeper insight into the behavior of the traffic in the network. We also calculate a bandwidth average to smoothen the short-term fluctuation introduced by traffic shaping. And why we use traffic shaping is the topic of the next slide. So we use traffic shaping to mitigate bandwidth constraints that are coming with NDTs, as you might know. Through the virtualization of real networks, you introduce inaccuracies because you do not have real devices that have hardware acceleration and so on. So you cannot put, like, let's say 40 gigabit per second through the NDT. And we mitigate that by scaling the traffic to a suitable fraction of the real world rate. So we scale it down to the maximum bandwidth the NDT is capable of. And we do it while preserving network characteristics. So it's a proportional scaling. And during our evaluation, we discovered that if we ignore the start phase, so there is some buffer in the virtualization working, but if we ignore that and tune the throughput a little bit and buffers, we get a comparable bit rate if we scale it. So the behavior of the network is somehow comparable. You can tell it on the graphs in the graphic. The blue graph is the real world or real network traffic, and the graph above it is the NDT traffic. So it's despite the fluctuations and the buffer at the start phase, it's pretty much the same. The improvements by the visualization, we have now a dynamic and fine-grained representation of the instantiated virtual network topology and a force-directed graph layout that dynamically renders this topology. So we improve the understanding by revealing structures under the influence of the forces, and we can also flick around the nodes and order it like we want to get the order of the topology like we want or we like to. And it's more easy to discover and observe patterns with the visualization as looking at purely textual data and trying to get an interpretation on that. And of course, our time machine functionality enables the users to recall certain events in this exact like real-time granularity. That means you can go back in time and have the exact granularity like you would have in the live mode. So you have the same data, and you can go like in the debugger back and forth and go step by step through the data and click through the nodes. And analyze the data given by that. So it's minimizing the blind spots and improves the information intake of the user. So scenarios that benefit from the visualization, as I said, is the traffic engineering. You can easily discover under and overutilized network paths. It's simply a visual thing. You see which paths are grayed out or colored red or green. And you also see traffic anomalies. If your traffic isn't flowing through the network like you expected it or it's supposed to, you see it instantly, as well as you can validate policies you want to integrate in your network or experiment with multipath scenarios. So another use case or scenario that would benefit from it would be the what if analysis or A and B testing, because you have the time machine functionality and you can spin up multiple Zyplinks next to each other and compare the historical data of a scenario to ease your decision on a configuration, for example. And of course, you can do stability testing, disable some nodes, and identify bottlenecks using that, or the behavior of the network reacting to the deactivation of the nodes. So you see the instant graphical response in the real-time visualization. What is to say about the scalability? So if you scale up the application or the topology, you have multiple things to consider. One thing is the GNMI subscribe reduces the management traffic compared to the periodic GNMI get, as we only transfer GNMI data when it's changed instead of getting the full data set. So that's a thing to consider when monitor bigger topologies, as well as you can only select a subset that you want to monitor. So for example, the transceiver monitor container in the GNMI dataset, if it doesn't matter for you, you can exclude it and only maybe take a look at the octet counters. So it also reduces the management traffic flowing from the NDT environment to your application. And another thing to say is that the Python deck does not scale well when the topology is bigger. So it's a proof of concept or prototype. And the thing you have to consider is if you stay at your polling rate of 500 milliseconds, but want to include the data of, let's say, 10 more routers, you have to store more data in the same amount of time. And that also increases memory usage. And you only have a time frame of 60 seconds to recall. So there is an persistence issue. And of course, the back pressure handling is a thing. So if you you rely on the log object or log element to write on the deck. So some workers have to wait to write while it's in use, and that decreases the performance. And to circumvent that, we would include Apache Kafka in the time series database to improve the scalability, and we expect to improve it tremendously. So coming to our conclusion in future work, we present a vendor-agnostic prototype for the real-time visualization that utilizes high-fidelity GNMI monitoring and telemetry with the functionality to recall historical snapshots. And we combined force-directed layout with multiple other visualization techniques like real-time graphs, colorization of links, and playing with the link width. And our implementation is available as open source. So if you scan the QR code, you can check our source code. And the next steps we consider, as I said, is replacing the DAG with Kafka in the time series database. So you can then have, for example, a week or days to monitor and to look back at and have an improved performance as you can parallelize and distribute the pipeline to store it in the time series database. And another thing to consider here is the integration of compression and deduplication algorithms, because you simply don't want to store so much data of such big time frame. So there's a thing to consider where and when to apply some compression in the granularity. Another thing we want to implement is an integration of flow data, for example, with SFlow. So we want to augment the basis of the interface data we now monitor to gain even deeper insights into the application traffic flows. So we think of it as another layer of information to improve the information intake for the user. And the third thing we want to implement is a tagging feature. So we want to be able to define thresholds of triggers to automatically highlight events of interest. So if you have to imagine to go through like hours or days of monitoring data, you maybe do not find events of interest in it. And if you can automatically highlight it and browse through the data using the time machine functionality, it would be also an improvement in usability. Yeah, that would be it from my side. Thank you for your attention. Do you have any questions?
So I think we should proceed to the questions. Heshan, you can go.
My question revolves around the usability of digital twin versus the complexity that it comes with. We actually have a paper published on this topic. You see, to build a digital twin, there is a process. You need to collect data, you need to process this data. So you need communication resources, you need computation resources, you need storage resources. And then the advantages from building that DT, is it justifying all those complexities? That's my first question. The second question is, what are the problems where DT is actually important? Is it everywhere or it depends? Thank you.
So if I understand it right, it's more general NDT questions that involves more the DixieNet environment as the DixieWiz environment, which does visualization. But I think the DixieNet environment we deployed here uses, there are also papers on it, and it involves continuous data exchange also through GNMI. So yeah, it's complex, and but you can abstract the real network into multiple subsets that represent characteristics of the real network, and to rebuild these characteristics. So I think that's pretty much also the use case. So if you want to, it's not suitable, I think, to completely represent the entire real network, but more or less the, let's say, some characteristic or parts of the network you want to play with. So that's for me a use case to look at. Maybe we can get in touch through email or in the chat it's a very big topic, so I cannot answer it in less than sentences.
Okay. So, Sheng, do you have a question? You can go.
Yes, Chair, can you hear me?
Yeah, we can hear.
Okay, a quick question here for the presenter. In slide 5, when you mentioned traffic shaping, so
Yeah.
can I know can you tell us the approximate fraction of the shaping? Is it different for different cases, like traffic anomaly or just policy verification?
So in this case, we look at the maximum throughput of the NDT and scale it like that. So we dynamically take a look at the bandwidth the NDT is capable of. So for example, we used FRR containers, and I think it was like 80 Mbit per second that the NDT was suitable to transmit. So we scaled it here down to 7 Mbit in the use case or in the experiment to do not even hit the maximum bandwidth. So we just we had a safe space like that where we could make sure that we do not hit the bandwidth constraints. Is it the answer to your question?
Thank you. Thank you.
Thank you for your question.
Okay, so thanks, Felix, for the presentation.
Thank you for the
So-
invitation.
Okay. So, next presenter will be this one. It's the second one, right? Yeah, this one. Visualization is this one. So the next presenter will be Sheng. So you can go.
Okay, so can I control the slide?
Just a minute. You should be able to control the slides now.
Okay, let me wait. Okay, I can do it. Thank you, Chairman and everyone. This is Chandra from China Mobile. I will present the draft update of network digital twin-based architecture for AI-driven network operations on behalf of our co-authors. A quick recap, this document focuses on exploring how network digital twin can be integrated with AI agent to enable AI-driven network operation and to support intent-based networking with generative AI and agentic AI. Actually, this work was briefly discussed earlier this year and on module meeting, and we have initial discussion. And after that, NMRG group hold an interim meeting on October 8 on agentic AI and for network management. On this meeting, we explored the problem statement, design consideration, network management deployment, etc. And we have drafted the key part of problem statement and use cases to the draft of agentic AI problem statement. Here we should say special thanks to Chris for his insightful input on proactive lifecycle versus passive lifecycle. Here's a summary of our update compared to last version. We added the security and knowledge sections. We clarified the relation between knowledge and tools, the source of knowledge, and clarified the key characteristics of network AI agent for adapting to environmental changes. Also, we added contents on collaboration between small AI models and large AI models. Coming to slides, just to clarify 2 points of AI-driven network operation and AI agent. AI-driven network relies on 6 key elements, including intent, knowledge, awareness, analysis, decision, and execution. And we believe AI agent can be a promising enabler to help achieve the AI-driven network operation. In short term, AI agent can equals to LLM multiplies the sum of plan, memory, tooling, and action. Here's the core architecture proposed in chapter for AI-driven network operation. In the core part, autonomous domain, it has 3 key modules: network digital twin, network AI agent, and the knowledge base. And with data collection and execution, we can build a closed loop. Here, for physical network, the network element should be with lightweighted AI to help the closed loop more efficiently. This slide just compares the 2 operational closed loop to highlight the value of AI agent. Without AI agent, we can see that the system is just a one-time reactive life cycle. With AI agent, the life cycle can be proactive, starting with intent recognition, and then identify users objective, and then use NDT and AI agent to verify the configuration and to execute and feedback with the closed loop. Next steps, we will continue exploring use cases of multi-agent and interaction logic between AI agent, knowledge base, and tools. We will also enhance agent security mechanisms, and your comments and suggestions are welcome, and also welcome to join us to work together on this draft. Thank you, Chair.
Okay, thank you, Shane. So I think we have time for just one question. Any questions? Okay, so I think we can go for the next presentation. So thanks, Shane, again for the presentation.
Thank you.
Okay, so now we can go for the second part of the session on agentic AI and LLMs. And the first presentation will be performed by Hesham.
Don't think this is mine.
Okay, sorry.
I'll try to present it if you want.
You're able to do that? This one?
No, this is just
This one?
no. Go down.
Yes? I thought it was in order.
This is this one. This is this one.
Okay.
That's more like it. Yeah, sure.
Looks better.
I recognize it at least. I'm the guy who's doing the glide there, right? So I'm just kidding. So good evening, everyone. So I'm Hisham from Huawei, Canada. So the topic I'm presenting today is about data and agentic aware inference and training network. This work is done in collaboration with my colleagues and Arashmed Akavain, he's right here. Okay, this is not going. Okay, content, nothing. So we can go. Well, it was hard to put some content slide together because there are some aspects here that we want to talk about, just as we're introducing this topic and we just submitted a few drafts in there. So we're introducing a big framework, but there are a lot of aspects that require research, and this is why we're bringing this here also. So without further ado, those are the drafts that we submitted. We also have a magazine, IEEE magazine paper as well that describes the overall framework of the DITN. But a quick background. We're all in the era of AI. AI is expanding its footprint. It's finding its way in every aspect of our life, in your phone, in your laptops, and everywhere, basically. And recently, we started to hear about agentic applications, agent-to-agent communication, agent-to-tool, et cetera, et cetera, et cetera. So things are going out of hand at the moment. But at the core of it is, for this to succeed, you need good and robust training, and you need a good inference framework. Inference includes agent-to-agent communication, of course. So for training, there are large amounts of naturally distributed data. You need to collect this data, or you can go visit those data, train your model on it, and that's the training. But it's a big cycle. There is a lot of communication that goes between the model and the data providers. For inference, it's the same. The only difference is now, rather than we're using the data to do training, we're actually using the data that the model, or the knowledge that the model has learned, to do our inference tasks. So I hope that you can see that at the heart of those two aspects, we have data and knowledge. So our problem that we're coming in with it is the traditional networks are not designed to meet the unique demands of AI systems, including training, inference, and agentic interaction, especially from the data point of view. Our network today is able to carry the data around, carry models, carry queries, but there is no sort of control or handling of the whole operation. There is no big framework that glues everything together. So this is why we're coming up with this data and agent-aware inference and training network. We need to be aware of the data, and we need to be aware of the information or knowledge that the agents or the models are possessing. So the goal is to build a unified, intelligent, and multi-plane network that supports the full spectrum of the AI services and fosters an ecosystem, delivering value to providers, clients, and enablers. So this is just, this is the ITN, yeah. So this is how we envision it, right? So we have different nodes around. We want to connect those nodes together. We want to give clients an access to this network. We need to give providers an access to this network so that they can connect together, so they can, clients can use the services of the providers, etc. And for that, we need a full network with interfaces and underlying network and a control plane and a data plane. And all of those details are in the drafts and in the paper. So I don't want to go a lot into this because I don't think this is where we should be discussing this. But if you want more information about it, we can definitely discuss later. But I'll go back to the point of the data here. And to do so, we have a use case. So imagine now that we have a distributed AI training scenario, meaning someone will come to you and say, okay, I have this model or I have this agent and I want to train it, but I don't have the data and I don't know where to find this data. So the objective now is to take this model, find the proper data for it, and then train it accordingly. And a challenge is, how do we train it? So let's say we found the data. Now, how do we train the model on this data in the most perfect manner and in the most efficient manner, yet keeping observing privacy and on other aspects of the data as well? So continual learning is one aspect here. So continual learning means we go from one node to the next node, to the next node, to the next node. So our research is about that. We introduce into this DITN an intelligent component that we call MTRCE, Model Training and Root Compute Engine. This is the entity that will take in your model, has a view into the data, understands your KPIs and requirements for training, puts the plan together, put the training plan together, and then ships the model to the nodes or the network and get it trained. Okay. Now, I said has understanding of the data, and that's the other aspect of it, which is DRRT, data resource and reachability topology. This is where we map the information found in the network to what we have or what we need. So now the model comes in, we have a big data corpus of distributed nodes, and now we want to put the right data sets together that are needed by this model to be trained. Now, the data set that we put together depends on the incoming model. So here I'm showing two things, like a red model and a black model. And the red model has the data sets suitable for it, and the black model also has the data set suitable for it. So the question becomes, how do we know the data sets? So we came up with a concept called data descriptors or data set descriptors, where we are trying to describe the data with enough information that helps us decide the training or choose the data set suitable for training, yet we don't want to reveal too much about the data. We also want to be as efficient as possible, so the data set needs to be as small as possible, or the data descriptor needs to be small as possible. So we devised some algorithms to run this continual learning. One of them is based on something called the NWAT. It's inspired from the neural architecture search, where we collect some mini batches. And those mini batches for us at the moment are data descriptors, but mini batches are samples of the actual data. So we're revealing too much, but it's a first step towards a data descriptor. But we were able to collect those mini batches, pass them through this NWAT algorithm, and then we can compute a score, and based on the score, we can select the sequence by which we can train the model. We also did another experiment using another algorithm based on Fisher. We also take many batches, pass it through the algorithm, and we compute scores, and we decide on the sequence. And we were able to do some experiments using these data sets, and we have positive results for both Fisher and NWAT. Now, NWAT is able to do better than random. So if you give me the model and I just randomly go and pick data sets out there, you will be performing at this black line. While if we trigger this data descriptors along with our NWAT, we're able to do a little bit better, which is the red line. Of course, it's not a foul-proof method. We have another experiment for non-IID, and it's kind of failing. But this is where the research is, right? Okay. Yeah, so we did the same for Fisher, and again, we're comparing to the random situation. Fisher is doing better than the random for those two cases. We also included our methodology along with other continual learning algorithms out there, such as the EWC, elastic weight consolidation, and it's enhancing elastic weight consolidation. So, some research questions. So this is what we did. This is our first take at data descriptors, which is collecting mini batches and samples, but those are too revealing. So what else can we use for data descriptors? What other algorithms can we use into the MTRC? Is an MTRC algorithm distinct for every learning framework, or do we have to come up with a new algorithm for every training framework we use? For example, here I'm showing continual learning and it worked. What about if I want to do federated learning? What about knowledge distillation? So there's tons of questions and research questions in this field. Same goes for the DRRT. Now, data descriptors, as we said, we need to build some sort of a map, a relationship between the different data sets in here. So how do we do that? Carrying those samples, is it enough? Do we stitch them together and build a map? What do we do exactly? So there's a lot to do here. I'm listing tons of questions. Of course, I'm not going to go through them, but I hope that you can appreciate the depth of the problem that we're tackling here. That's all. Thank you very much. Any questions?
Questions? So, Roberta, you can go. just enjoy the time. We would like to advise for the next presenters that the time is for the presentation itself and also for the questions and answers.
So I have
Just to
4
make sure.
minutes.
Yeah, you have. You
Oh,
still
okay.
have on the.
Hi.
Can I use them? Yeah, sure. Go ahead.
Yeah, this is an interesting topic, and I'm really interested into it. My question is related to how do you think that the progression of this framework might work with the overlying issues that we have currently with, you know, the transport layer, right? The protocols. We have not solved a lot of issues yet that I think the framework will need to work, and also the part of the training related to like how hallucinations might be a part of the security issues that I was speaking with Rashid actually before.
Okay.
And what do you think about those topics? How that fits to the overall framework actually?
Okay, so let me try to repeat the question. You're asking about the framework itself and how it integrates with the other transport protocols that people have been talking about in IETF. Well, we see this as an overlay network. So it's kind of in the application layer.
Separated then.
Yes, but still it needs to integrate with the underlays as well, because we have a lot to request from the underlay. So people have been talking about agent-to-agent communication, and that's what they are trying to do, agent discovery itself. But we think that data as well needs to be discovered. I just said data descriptors is you can think of it as the agent card. We have also data card, but we need to discover them because people want to use this data in a certain manner. So there will be underlay protocols as well for training data. Agents themselves might use the data to do some inference. So you need to discover data. You need to allow agents to discover data. So there has to be a connection between agents and data. That's not being carried today or discussed under agent to agent. So I think there's a lot to be augmented in the underlay as well.
Can I just do a follow-up question
Yes,
about
please.
the agents to agents and agent swarming, because those are like big roles into the data itself. How do you see the architecture? I saw you put a point about architecture as big issues that are not answered yet. How do you see like the progression of architecture of agent swarms playing a role in this, for example?
For agents playing a role?
Yeah, agent swarming is like the connection underlying.
Sure. That's a great question. We're actually thinking about implementing this as agents in itself. So there's those intelligent components that we're talking about within the network itself, within the framework, such as the DRRT, MTRCE, tag, all of those things, they could be implemented as agents themselves, so they can utilize those agentic protocols. So I think there is a lot of potential here. I hope this answers the question.
Yes.
Okay.
Thank you.
Thanks for the questions.
So we have one more question from João.
Thank you for the presentation. You have a very long list of questions at the end of research questions, right?
Yes.
Of course, you cannot enter in all detail now, but I was wondering, do you have priority on these questions? And second, do you expect some inputs on this question from the group, or what's your approach for these questions?
Definitely. So we are a team of 4 people. So 2 of them are here, so the 2 other people are working. So we cannot do everything our own. So we're seeking feedback from people. Some of those questions might be far-fetched. They might not be even needed. But this is our take on it. And please help us curate this list. Help us work on this list, see what you can do, advise us. Maybe we're doing something wrong, for sure. Yeah.
Okay. But you don't have yet, let's say, priority for this question, or do you have already priorities for these questions on it?
Priorities, yes and no, because we don't know if the framework is moving forward or not, and what will actually stick at the end. But we know that DRRT is our priority at the moment. Answering how to connect people to data is the important question here.
Okay, thank you.
Thanks.
Hi, Raj.
Just a quick one.
Yeah, quick one. Just to add in terms of priorities, as Hisham actually said, the data descriptor and the data topology are the priorities. Why? Because in addition, right now we're only looking at this from the AI point of view. But for people like Diego, for example, we might actually be able to use the data descriptors to actually use it for data governance. We don't want to reveal the data, and that might be an interesting thing for the Europeans. The idea of that understanding data without revealing anything about it, but just expressing it in a way that people can actually understand whether it can be usable or not for their purpose. Even if you are doing centralized training, you will be saving a whole bunch of communications, the storage, and GPU resources, because you're not sweeping the entire internet. And by doing so, you might be able to attract people who have data, but those data are private, and they're not willing to put them on the internet. So essentially increasing the capability of your agents and model and things like that, right?
Yeah. You can go, yeah.
So
you have to write to answer.
No, that's it. No, simply since Arashmita has named me, this is something that we are interested. We have been looking about how to expose characteristics, metadata in general, because we're talking metadata here, right? And how this metadata can be mapped on a semantic field, and how this can be associated with data contracts. No, it was data agreement. So we're trying not to use contracts because people are misusing that. I think there is a quite interesting things proposed here that are worth exploring. My problem is that, for example, for me, there are some issues regarding training, etc., that are difficult for me to understand where the complexity are, because we have not experienced with that. And Roberta was mentioning that the transport problems. Again, I'm not familiar with those transport problems. I mean, I think it would be really interesting to understand them, because I believe that probably it's because of my extremely old age. I believe that many of these problems should be solved or could be solved by reshaping a little bit existing protocols. I would say that in most of the case, we don't need new protocols, but new ways of using them and combining them. That's okay. Then happy to talk about this later on. Good.
Okay, so just a small reply from Mahashan, and then we'll finish.
Less than 10 seconds. Just so I make sure that the data descriptors are not simple metadata, so they're not size, number of samples, etc. It's something meaningful for others to be able to use them. For example, for training, I care about the quality of data rather than the number of data that you have or the number of samples that you have. So I just wanted to make sure it's more than just metadata. Thank you.
Thank you, Hisham. So now we have the presentation of motivations and problem statement of agentic AI for network management from Yongshan.
Hello, good afternoon, good evening. My name is Young Hong at Daejeon University in South Korea. So this is the motivation and the problem statement of agent AI for network management. So our team is to me and Ju Sang-yoon at Dongyu University and Uchin at Hawaii and Big Reze at Everything Office. Oh, sorry. Okay. This is the history and status. So in the last month, we present at the first time, and after that, we present. We submit a 0.0 version, and this is the second time. Okay. This is object of this draft. So from last IETF meeting at Madrid and this meeting, agent AI and AI agent related internet draft and the presentation and the side meetings are many. So I think that the agentic AI is very related to network management, because network management is too complex and there are many component agents and we must consider many things. So to resolve, the best way is to utilize AI agent. But in this draft, we do not propose any solution or any method. Before that, we want to identify agentic AI is suitable for network management and what is the objective. So that's the reason we submit this draft. So we want to align the key object of agent AI in the field of network management, and we want to highlight the fundamental issue with the existing technologies, and we want to emphasize the necessity for relevant groups because in the last month when I present, I found that there are many issues, for example, security, and network function, etc. So in NMRG, we do not handle that kind of issue. I guess other relevant groups can handle that issue. Okay, so you know that agent AI in network management is a good match because unlike traditional automation, which relies on pre-programmed rule, agent AI applies autonomous decision-making capabilities, for example, LLM. So agent AI is suitable for network management. So agent AI utilizes LLM to encompass a broad range of capabilities beyond natural language processing, including reasoning, problem solving, interaction with the external environment, and performing actions. So it is the conceptual diagram of the operation of agentic AI for network management. So the first one is the goal, intent, decision, and then we utilize AI agent, for example, LLM, and then we do plan, reflect, execute, and then we can use the external tool use, and then we can apply the result to the network management. So we found that the sixth problem of existing technologies for agent AI, the first one is the architectural bottleneck and the failure of centralization, because existing AI and autonomous systems have often relied on centralized infrastructure for data aggregation and heavy computing. However, this centralized model cannot handle the volume, velocity, and distributed nature of agentic AI workload. The second problem is the absence of agent-to-agent A2A semantic interoperabilities. The third problem is a lack of dynamic trust and accountabilities in autonomous behaviors. And the fourth problem is the real-time data validity and the resilience issue. And the fifth problem is the problem with existing IBN systems. That is the rigidity of the intent translator engine. And the final problem is they relate to ANIMA ASA autonomic service agent because it is too simple to handle the complex large of the network and resource management. So before making technique or method to resolve that kind of issue, we want to make the object to apply agentic AI for the field of the network management. So the first object is to autonomous network operation management. So beyond minimizing human intervention, it must implement a self-driving network that autonomously recognize, diagnose, import, and resolve issue even in unpredictable situation. To do this, the key feature is to predictive and proactive port management and intelligent root cause analysis and autonomous configuration and optimization. The second objective is to intelligent and dynamic resource orchestration. to address unpredictable traffic demands such as 6G, holographic communication, and large-scale IoT. Network resources, for example, computing, storages, bandwidth, are allocated and coordinated in real time and proactively. So to do this, the key features are dynamic network slicing, cross-domain resource negotiation, and edge computing resource optimization. The third objective is to predictive, adaptive network security. Beyond defending against known attack patterns, AI agent autonomously detects unknown zero-day attacks or advanced persistent threats and recognize defenses in real time. To do this, the feature are autonomous threat hunting and response and dynamic defense posture. The fourth objective is to enabling a novel network service model by transforming the network itself into a single best distributed AI platform. It enables new communication services and business model that were previously impossible. The key features are intent-driven service creation and semantic communication. The final objective is to autonomous, high fidelity, and action-aware network management to turn low network telemetry into trustworthy, context-rich insight that continuously retain itself, explain its own uncertainty, and feeds closed-loop control without human analytics. So the key features are semantic anomaly narrative and root cause metrics, and self-driving measurement campaigns, and counter predict what-if metrics. So if we utilize the objectives, we draw three use cases. The first one is intent-based service delivery. So in this use cases, the LPI language program interface we use, then we can utilize it to the network management. The second use case is to cross-layer and cross-domain multi-agent communication for complaint handling. So that is kind of the automobile manufacturer field. So some complaints are raised, then we can utilize the agent AI to resolve that complaint. The third use case is AI agent-driven network management. So also in this scenario, we can utilize the agent AI to solve the problem. Yeah. So that's all. Okay, thank you for your attention.
So thanks, Youngjan. We can go to Rashmid.
So can we go back to your few slides at the beginning, like the slide where you were talking about point two? I'm sort of confused about that. When you talked about A2A and it's lacking something. Oh, there we go. Absence of agent-to-agent semantic interoperability. What does it mean? What do you mean by this?
Okay. Now we have the many implementation or many sources of the A2A implementation, but we believe that the interoperability, more the semantic point of view, the interoperability is some missing point. So that is the one of the problem to design or implement the agent AI cases. So that's what we want to emphasize in this area.
Are you referring to the different protocols that are trying to cover that area, like agent A2A, ACP, and ANP and things like that?
Yeah.
Okay, so if everybody basically converge on A2A, then we won't have that problem, right?
Okay. Yeah. Some point you are right, but to realize and to implement the real agent AI, we need more the implement issue. For example, the semantic cases. So until now, the the syntax interoperability is maybe solved based on existing technologies, but if we focusing on the semantic interoperabilities, then we need more function to do this. So that's the reason why we did it.
So you can move the conversation for the mailing list. Thank you.
I'll ask later on.
Thanks. Roberta?
Hi.
Hi, thanks again.
Hi. Yeah, so I have some questions regarding the last part about the security considerations.
Security, yes, you are the expert of security.
I'm sorry about being so obnoxious on the other meetings. Actually, it's more regarding how it's who watches the watchman, right? If you want to do security with the agents itself, and we have a basis that the agents are not reliable because of hallucinations and disobey, right? How are you addressing this part of the overall schema? I saw your schemas. I took some pictures to later address it with you if you have some time. But how are you intending to do this part of, preventing security without using directly the agents because they can be unreliable as well? Are you thinking about only using agents for those parts?
Okay, so actually, I can't answer your question because I'm not expert of the security. You are the expert of the security, so you and your group can do the problem. So I hope your anticipation.
We'll try. We'll try. Yeah. Thank you. Yeah. Another thing, right? This is like a proposal, or are you trying to implement already? Maybe one way of those applications being able to do those kind of stuff. This is kind of a contextual proposal, or is this already something that it's being cooked on?
So in the last the interim meeting, we show the implementation, for example, physical AI, but in the implementation, there is no relationship to a network management issue. So we hope in the next time we bring to more enhanced content, the implementation or some practical use cases in the next time.
Awesome. Thank you.
Thank you. Marcos, you can go.
Okay, can you hear me?
Yes, we can hear.
Okay, so working with agentic AI and AI agents, I saw that many problems we can solve by the existing automation solutions that we already have. So, do you think the role of the AI agent will be plan how to do the things with the intention received? Do you think this is the main objective of the AI agent? What do you think about it?
Okay, I trying to understand your question. So, okay, so to answer your question, yes, there is some relationship between AI agent and the intentions. But we can utilize some existing solution, for example, IBM or some the intention-based mechanism. So picks or the identify the intention is the first step of the agentic AI scenario. So my assumption is that we do not propose any new mechanism, any new methods. Instead of that, we can utilize existing solution, for example, IBM in the developed in the NMRG or other solutions. Is it acceptable to you?
Okay, thank you. You can discuss it later in the meeting.
Okay, Jerome.
Yeah, thank you for the presentation. It's a kind of follow-up related to the last question, actually, because on your presentation, on your slide, you have objectives of agentic AI for operation and management.
Yeah.
But the objectives that you describe for me is more general regarding, again, automation, or autonomous networking, maybe. So agentic AI for me is more, how it's presented is more like a kind of solution of approaches to solve challenges or objectives that we have already before, that maybe we are not satisfied with the solution, but maybe it can be good to see if there are new objectives that we do not think about before with agentic AI. But for me, as it is presented in your slide, it's more objectives that we have already before. It does not come from agentic AI as objectives.
Okay, thank you for your comment. Yes, you are right. So it is very early 0.0 version. So in this version, we do not cover all of the issue perfectly. So in the next time we develop, then we can include resolve your comment in the next revision. We hope so.
But just to clarify, it does not mean that you have to have new objectives.
Yeah.
But if you say there are objectives of agentic AI for network management, we have to be clear as a new objective, and not that the agentic AI will help us to address challenges that we have already objective before. But it doesn't mean we have to have new objectives. You understand the?
Okay. Thank you for your comment.
Just clarification.
Okay.
Okay, thank you, Young John. So we can go for the next presentation. The presenter will be Huamin.
Thank you, everybody. Since this is one of the two series of the proposal, and we want to touch upon different problem statements as well as the use cases. The project, the proposals are based on our projects called a VLM semantic router, which is under the VLM projects, which is a PyTorch Foundation project. So we are extracting the actual project's implementation into the proposals. So the idea is that when we are expanding this routing capabilities to a broader ecosystem, as well as the telco use cases, we will appreciably using this proposed enhancements for semantic routing to get the best security, performance, cost benefits for multiple vendors. So the problem that we are identifying in our project's development is that whenever you are using large language models using API access, you have to be very specific for lots of other things, just like say which model you are going to use, which capability you are going to enable, like a reasoning or not. Do you want to have tools callings, things like that. So as you can see, this is a huge undertaking for the programming side as well as for the provider side. If you are wanting to interacting with multiple vendors, you're going to see that it's not something that you can scale very easily. So people are trying to work around these issues by providing metadata, typically in HTTP headers. As you know, the metadata without regulation, without standardization will be very messy. It's going to be very vendor specific. It's hard to interpret, and worst of all, you can manipulate the metadata to game against the system. The other case we are looking at is that for lots of security awareness cases. For example, if you are using the public models and you are sending personal identification information, also known as PII, then you are going to be in big trouble. The other thing is not every model is suitable for all the workloads. If you have simple queries, like just say what's the temperature of the day, you do not need to have the most sophisticated models to satisfy your query. So this the performance versus cost trade-offs is always the problem when you are using the models in public. So what we are proposing, semantically to interpret this information, workloads while we are using the very standardized HTTP header schemas to enhance the routing and model selection processes is the protocol that we are trying to develop. Actually, we already have some of the capabilities available in our projects. So what we do is that we have an analyzer sitting in between the workloads and the vendors. The analyzer is also called as the semantic router in our projects, using the language model on the other side to identify what is the content of the prompts. It will categorize whether that is for certain examples, like is this a math problem, is this a coding problem, and so on and so forth. It is also identify what's the sensitivities in terms of security concerns, whether that's low security concerns or high security concerns. Does this contain PII? Does this contain jailbreaking? This is the typical machine learning classification examples. And we can also take examples of how to identify the complexities for different reasoning capabilities. Is this a complicated query that requires reasoning? Because at the end of the day, reasoning does not come as free. It really comes as the cost. Typically, we see in reasoning models, you produce anywhere between 2 to 10 times the number of tokens and also the latency to get the drop down. So we are trying to identify the workload in the upfront and trying to optimize the inference backend for producing these outcomes. So what we are trying to standardize is the HTTP headers in this space. Once the classification of the workloads is done, we raise all the necessary HTTP headers to indicate what is actually contained in these workloads. So any of the downstream providers, large language model providers, have used these headers, or any of the routing intermediaries in these downstream processes have used these headers for further enhancements or further routing processes, and add certain value-added modules in between. So this is a very high-level architecture of what we are trying to, what we are proposing. So as the front end, you deal with the large language model query clients that send the queries or prompts into the router that has the implementation of the protocol. The router has its own classification models sitting inside. We classify based on all these requirements, category-wise, security-wise, complexity-wise, give a score. And then once this score is given, we create the necessary HTTP headers and then relay the messages to the downstream processors with these headers turned on. Any of the downstream processes, when they are looking at the contents as well as the header, they will determine what's the best efforts to satisfy this request. The router itself can also make decisions for certain security and complexity concerns, or also the availability concerns, how the routing could be done in the backend. So at the moment, we are talking in this proposal, we are only talking about how the headers will help the routing processes. But however, the backend is discovered and security protocols are negotiated, is left to the future. This is the list of the headers that we are proposing and what's the reasons for these headers. Once they are the contents are being analyzed by the language models. So for the category, we propose that certain categories can be standardized, like I said, math, coding, and business. This is the non-exhaustive list, but once we have these meaningful identifications in the category, it's become easier for the models or the routing processes to pick up the best processes for the model. Just for reference, not all the models have the same capability in each of the categories. Some models doing better than the others. All right. And then when we have the sensitivity categories turned on, sensitivity headers turned on, it will indicate what kind of information sensitivity you want to have to processes. If it contains highly sensitive information, you probably want to block it from getting into the backend at all. On the other side, if there's something safe to have, you can send it to the public models. And then you can also indicate complexities and how you're going to apply additional information to the policy. We add some of the value-added potentials. For example, if you are looking at the complexity and you see this is a low complex prompts, then you probably can use the cheaper model to handle it. On the other side, if you are using the headers to indicate the urgency, then you're going to use the low latency backends for this exam, for these workloads, and so on and so forth. And we add some of the examples to illustrate how that could be implemented in the different vendor-specific scenarios. So this is just to give you one of the examples. For example, if you turn on the category headers, and then you will classify this as a math, then you potentially are using the most sophisticated model for that prompt. On the other hand, if that is the coding problems but contains sensitive information, then you're probably going to raise the category as well as the sensitivity headers so that people will understand what's the consequences of handling these models, whether that is to be rejected upfront or be handed over to the background. So we do see this as opportunities for the community to converge and take actions, and we are looking for reviews. And for if you have further interest, these are GitHub repositories for the examples and how the implementation could be taking shape. Thank you, and now we'll take the questions.
So for the first question, Roberta, you can.
Okay. Okay, Huang Min, very nice work. But I have one concern because you expose your content to some engine, but the problem is we need to trust that kind of engine, to perform some inference, right, to make right decision.
That's true.
Yeah. So the question is it possible in reality we expose our every privacy, like a password, an ID, something like that? So do you have some justification?
Yeah. So I think the typical deployment is as a reverse proxy that you deploy as your enterprise boundary. So before it's getting to the internet, so that's where just best serve the interest of the privacy. If you are also trusting this is obviously we have the security experts inside. Obviously, this has to be some of the trust built between the providers as well as the gateway. So that's something that we need to negotiate. That's what I said. This is as an early stage how this negotiation could be done. But our typical, because we are working for the kind of enterprise, the typical use case is enterprise will deploy it as their edge, so they can use it as a egress gateway.
Okay, I see.
Thank you for the question.
I think I will not have enough time to address.
I have another one, so I can just use this question, and then I will cut off my next.
I have 3 areas. One is the same, who watches the watchman? If your control is being done by AI, and even if it's internal, even if it's in a closed environment, you cannot rely only on the perimeter. You have to think about zero trust. And this is, I think it's something that by your architecture, I think it's something that it's plain on over there. The second thing that we can discuss later is that headers are usually a fountain to different types of injection, not just the ones about AI, and then the AI injections itself with the content. So I see this is a really good idea, but I think you still have some particular things about security on headers and security with how we usually do prompt injections that you need to consider, because we are passing the CDNs and the proxies right now. So they're not safe for some types of attacks for AI. So this is kind of
okay. I think we need to have this negotiation processes to have to happen before everything else will be processed.
Yeah, the protocols should be.
Yeah, I would advise for maybe revision on the draft, considering the security perspective.
Yeah.
So I think it'd be a good addition. So,
okay.
But if you can do that,
I'll be honored.
It would be nice.
Remind us we can think of time.
Thank you.
Yeah, thank you.
Diego.
It's me, right? Yes.
Yeah.
No, just a note of this, because we have been discussing about this, well, a while before and the week before, etc. From our point of view, some of the concerns that Paul and Roberta has expressed probably would be addressed if the router is more located. I mean, it's more to the local part of the connection and not to the remote part of the connection. You know that this is something that is the case we have in mind. Probably we can elaborate about this later on as well, because, for example, these kind of injection cases would disappear because you would locally you would consume the no, well, Well, that's something that we have discussed.
I think we have more than
No,
one
because
reasons to be done.
the trust environment is different, but yes, that's something
Okay.
that's anyway. And and it's the same. When you decide to expose your data, I mean, you're deciding or you can decide where to expose your data. So the policy regarding where to expose your data can be taken locally as well. That's I think that I mean, you're right that it can be attacked. Yes, that's true, but it's a different environment. But anyway, that.
Okay, thank you. So next presentation will be also for my home.
That's the other one. Okay. So what we just discussed is between the gateway and the provider. And so this one is discussed between the application providers to the gateway. So, if you are thinking about the previous one, that is more for the backend. You can think of us in that way. This is more for the user facing front end. How that negotiation could be done to facilitate the model selection for the same benefits. All right, that is a little bit distinction. So what we are, this goes back to the original statements, problem statements. We do not want to have the vendor lock-in. So if you are working, if your one for applications is designed for one of the vendors, like just OpenAI, we do not want to say if you are working with a different vendor, the application will be broken. Right. So this is the vendor neutral statements we want to provide. The second is that you do not want to be model lock-in. So if your wonderful applications were written for GPT-4, you want the same upgrade experiences to GPT-5 and 6 in the future. And the third is that not all the models and all the vendors have the same capabilities. Some can support models as tools, some cannot. So you want to facilitate every possible differences in this premise. So what we are trying to do is trying to set up the certain negotiations between the front-end applications to the router. So what we start is the auto parameter. The auto is picked by us, but it does not have to be the only way. You can just say any of the parameters that could be standardized. The idea is that by replacing vendor or implementation specific parameters with standardized parameters, we are going to eliminate lots of dependencies for vendor specific implementation. So we have identified several of these situations where the auto parameters could help. And by the way, these are all implemented in our VRM semantic router projects. The models can be auto. By the router, when the router sees the auto model, it will just pick up the best one to serve the request. The tools can be auto. If you are just calling for something for browsing the web, you could use anything like just Firefox, Safari, any of the tools that are available by the vendor, not specific to one specific tools set up by the application. The reasoning mode can also be set to auto. If you don't know your model's capability or don't know your workload's complexity, you set to auto, and then the router will be able to identify the best processes for that enablement. So by using that auto parameters plus extension headers, again, these are application facing headers, we are setting up for the vendor neutral implementations in the future. I'm quickly going to a diagram first, and then I will just go straight to the questions, because this is a little bit different, similar to what I just talked about before. So, but just to keep in mind, this is a front-facing architecture. So when the clients sets the auto parameters to any of the fields, in this case is the model, the gateway, we're just looking at the backend configuration and pass additional headers and take great actions by selecting the best models and capabilities to process that workloads and get the consistent output for all these similar queries. That is what we are proposing. And for more implementation details, welcome to our GitHub repo, by the way. All right, I will more than happy to answer questions for the next 20 seconds. But I do like the idea of how deployment in real world will work and how the security will be enhanced in that process. So I'm more than happy to work with you folks and come up with a revision.
In this case specifically, we can speak about a light element and other gateways that are provided are being used. And one of the issues is redundancy and failover. So we can speak later.
So that is provided in this one of the examples, like just auto failover. So this is something that we can definitely work together. All right. Thank you for your attention, and sorry for duplicate the problem statements for twice.
Okay, thank you, Ramin. So the next presentation will be a framework for LLM-assisted network management with human in the loop by Ming Che.
Yeah, okay. Okay, Kai. Okay, thank you.
Probably can just type it.
Yeah, okay. Okay, everyone. I'm Min Zhexin from Beijing Zhonghua Laboratory. I'd like to introduce our updated draft. It presents a framework of using the large language model agent to assist network management while keeping human in the loop. So in this slide, I will first give a quick refresh of the motivation and background of the last 0.0 version. That I introduced some updates since IETF 123 and our future plan. So the motivation is that the traditional network management still faces some challenges, including that the network environment is still very dynamic, and the intent diversity and the rapid evolution of the network environments, and some learning curve of the specific devices. So the future vision is to build a autonomous network management as stated in type form IG 1230. And a core opinion of the autonomous network management is that even in the level 3 and level 4, the human operator will still participate in the network management process in the long-term future. So an opportunity is that the large language model, which provides powerful multimodal data understanding and logical reasoning and generalization ability. So many recent research work focuses on this domain to demonstrate its effectiveness in some classical network management tasks. So aligning with the NMRG charter, or my research question focuses on the large language model agent assisted network management with human in the loop. And the first question is that what is the framework components should be involved to build the intelligent autonomous system? And the second is the workflow of the autonomous agents and the human in the loop. And the final is the interface of the human operator and the agent system. So in the first version of our draft, we define 3 key components to form the network management framework. The first component is the enhanced telemetry model, which improves semantics of telemetry data by injecting some auxiliary information like the schema definition into the context. The second is the large language model agent decision model. It specifies task instances associated with some access control defined with FCL H341 to generate the device configuration. The third is a human operator. All this configuration passed by the validation and access control module. So we have some updates since IETF 123. The first part is the discussion of task agent communication, including the model connect protocol and the agent-to-agent protocol. which also has attracted great attention in recent IETF meeting. So the task agent interacts with the tools, including the Python interpreter, Batfish, which is a network verification tool, and some servers through the MCP client. And the MCP sends requests to MCP servers to invoke these tools. The agent-to-agent protocol is used for the inter-agent communication, whereas the human operator can also be treated as a special kind of agent. So we also discuss some requirements of the MCP client and the server. For the MCP client is responsible for serializing requests and manage authorization sessions, handle timeouts and retreats. For the MCP server, it should expose some manifest, including the tool names to distribution, input and output schemas. And it also validates the schema and permissions for long-term operations. For the design principles of the A2A, it should support the decentralized orchestration and the internet-based messaging and this state-aware handoffs. We also give some discussions of the task agent lifecycle operation. We present the simplest three lifecycle stages of the agent, which includes the creation, updates, and the deletion of agents. In the agent creation, we need to pass the intent, which is a high level of objective of the agent functionalities. It also needs to select the template, the prompt template, and allocate some resources, including the GPU, CPU, memory resources. And given the selected prompt and maybe the few short examples and the two descriptions, we can initialize the complete context of the agents. Then we can register the agents into the the regions center. For the agent updates, the agent may change its configuration, like the switch to use another foundation large language model. So it should support to swap the model and the corresponding model weights. And during the updates, the intermediate state should be preserved. After the task is finished, we can shut down the agent, archive this state into a database, and deallocate the resources and deregister the agent from the registration center. The more details description of the lifecycle management can be found in our latest version of Draft. We are currently deploying a very simple network environment to implement the agent-assisted network management system. It consists of 2 routers and 3 servers, 1 GPU servers, and 2 traffic generators. We also have developed 4 basic agents, including the internet understanding, policy generation, computer generation, resource evaluation agents. The multi-agent is developed in a language framework. We will conduct some experiments on some classic network management tasks in this environment and release the code upon it's ready. The draft is also in the GitHub, and we welcome contributors and some issues and PRs. Okay, that's my presentation. Any questions? Thank you.
Thank you, Mite. There are questions? No questions? Okay.
I have one question really quick. This has also considered the issues that we have underlying with MCP and agents-to-agents protocols related to security, because this is going to play a big in what have you proposed. And I think those are considerations that might be put into the work, because as it is right now, I think there are some stuff that will not work as intended because of the protocols, security-wise, right, for the proposal. But we can speak later. I'll be more than more than happy to exchange contacts and see about this. Thank you.
Okay, thank you. Yeah, there are actually some of the security issues in the MCP and the A2A protocols, and we can see a lot of research papers discussing this topic in recent research papers. Yeah, we will add more discussions in the drafts, and maybe we can speak later. Okay, thank you for the comments.
Okay, thanks, Ming-Che. The next presentation will be Model for Distributed Authorization Policy Sharing by Lucia.
Hello. Hello, everyone. Hello, everyone. I'm Lucia Cabanillas, and I would like to share with you some ideas around authorization policy sharing in distributed environments. I presented the draft or the core idea yesterday in the NMRG group, but I thought it could be interesting bring it here as well, as there are some open questions that might benefit, but let me start first with the why. As distributed and automating systems evolve, authorization policies need to become more dynamic and context-aware, because static policies simply cannot keep up with adaptive, intent-driven operation. In such complex environments, authorization policies are everywhere, but the problem is that they are all fragmented. Each domain, each platform, each environment manage its own policy languages with its format and tools, which makes it really hard to validate, share, or update them. So the question will be, could we define a common model or a unified model, perhaps GAN-based, for expressing, updating, and sharing authorization policies in a matching, readable, and interoperable way? So what I have been working on is whether GAN could serve as a canonical representation of authorization policies. GAN already provides us a well-structured, extensible modeling language that could be useful here for representing authorization policy in a consistent, matching, readable, and shareable way. On top of that, we treat policies as code, which will allow us to find granularity policies even at the data level. And as it is code, you can do whatever you want. And policies can take into account context information, which is essential in network environments where policies may need to adapt dynamically based on the context, such as the topology, the risk assessment, or contextual information about the request. So the idea will be to cover the entire policy lifecycle, from creation and validation to versioning, distribution, and decommissioning. But if we think about what distributed policy management really needs, there are several requirements and perhaps several open questions behind them. Granularity, who doesn't want granularity, but we should think about what we like to take into account. Context awareness, as I said, policies may need to adapt dynamically. Token alignment, policies may consider the claims encrypted within the tokens, and there are other groups already defining the information that should be included there. So we need to be aligned to make sure that these tokens include the information that we need. Lifecycle control, how do we manage creation, validation, retirement, interoperability? What I think is that each of these areas will open different research directions, and I have all identified some of the requirements. And as we are thinking on policies code, the next natural question is, where do these policies come from? In many automation systems, as we have discussed, these policies are sent as an intent, expressing what the operator wants to achieve, but not how that intent should be realized or enforced. what I have been working on or trying to address is what an intent must include to be automatically transformed into a consistent, enforceable policy code policy. To achieve this, we will need to define a shared semantic layer, agreeing on common concepts such as actor, resource, action, context. And another key aspect that I am trying to address is how could how we could maintain traceability in this translation to ensure that the final state was as desired. Um, and perhaps we could consider JAM-based models to represent this, the intent metadata and the generated policy logic. This is how the JAM model looks like, where each policy will include metadata such as the identifier, the version, or the policy language, the declarative logic. This will be the policies code, which can be expressed, for instance, in Rego or CIDAR, which are different policy languages that are based on the concept of policies code. Optionally, provenance information, for instance, using cause signatures. I know there is another draft on signing messages is a model in Jan that could be useful here. So that's all. This is the very first version of the draft. So I am open for feedback, and I have identified some points for collaboration. First of all, feedback on requirements and scope. The integration of intent-based networking into policy as code. I know there is another draft on intent translation, so we could discuss how we could be aligned and how policies could be exchanged. That's all. Thank you.
Okay, thank you, Lucia. So I have a question. First, thanks for the presentation. You know, you use some in the draft some terms from the let's say old school policy-based network management like PDP and PEP. But
policy administration point, the policy decision point,
yeah,
and so on.
And I'm used to this, but I don't really understand what's the relationship between this PEP and PDP with the policy administration point that you also mentioned. So, because in the old school policy network management, there is this repository, the PDP and the PEP, and that's it. So, if you could, you know, just explain a little bit about the relationship between these entities, it'd be nice.
The idea will be that the policy administration point will validate the policy schema in JAM format and will extract the policy as code logic and will distribute it to the corresponding PDP that will, at the end, produce the authorization decisions based on this policy as code. I don't know.
Okay, so it's the function of this administration is to validate the intent, something like that, and to verify some.
Could be.
Yeah, because this is something that maybe you should provide some reference, maybe, because it's not, you know, for the PDP and the PEP, they are more common entities in policies, but for the policy administration point, I think it'd be nice to have, you know, like maybe you don't need to describe on the draft itself, but maybe just to provide a reference. But again, this is very interesting work.
Thank you.
Questions? Okay, so let's move for the next presentation. It will be Thomas. Thank you.
Hello, everybody. So at NMOP, we have two existing documents describing Yang push to message broker integration, so architecture and also schema. This is the third document regarding message keying. And we are coming here to the NMRG working group because you have documents regarding digital twin architecture, and we have a couple of questions for you at the end. So as a network operators, we have a dream. Instead of logging into routers and doing show commands, we want to do SQL commands on a message broker. without accessing the network, without having any database. This is not rocket science. This is something we actually already do since a while. Just some terminology on message broker, which I'm using later in the presentation. Some of them regarding Yang data taxonomy and indexing. To start at the beginning of the Yang data processing pipeline. So in this example, we have two nodes with two identical subscriptions. One subscription does in IETF interface periodical subscriptions for statistics, while the second subscription, also on IETF interface, subscribes on change sync on start, so basically the state of the interface. Since the subscription IDs are unique to the router, means basically we have 4 subscription IDs. And when we move up to the chain, there we go. When the Yang data producer, so after the Yang push receiver, when it goes into the message broker with the Yang data producer, and it registers the Yang schema tree for each of the Yang push subscriptions. Since the Yang push subscription 1 and 3 share the same schema, and the schema registry does schema comparison, at the end we will have as input 4 subscription, 4 Yang schema trees, and as output 2 Yang schema IDs, schema ID 11 and 12. So in other words, the subscription IDs in Yang push are locally significant. The schema IDs are network significant. So in the message broker, we have topics and we have subjects. So each of the Yang schema trees is a subject within, and it's being serialized within the topic, and that topic is being balanced over partitions among multiple message broker nodes. And then the messages itself are grouped in so-called segments. The so-called telemetry message schema is basically the standard schema used in the serialization between the Yang data producer and the Yang data consumer. We have normative text describing how Yang message keys and indexes are being generated. In red, I have an example. The second part of the document describes about the Yang message broker topic naming. Here, basically, we take also the schema name plus the Yang push subscription type. So in periodical subscriptions, that would be statistics, while in on change sync on start, it would be states, and in on change, it would be state changes. And we put that also into the topic name. So that gives us then the unique capabilities with wildcards to actually to subscribe either to all Yang metrics or only to statistics or states of Yang metrics or specifically for a specific schema. Now, since the schemas are being populated from the Yang schema registry to the stream catalog, it means an application or a human can discover through the stream catalog what data is available on the message broker and subscribe that topic. Now, with the solution we are proposing is we know now exactly which subscription or which schema is in which topic, but also through the message keying, it allows us to consume a subset of the topic. So for instance, let's assume for the moment I'm only interested in IETF interfaces for a subset of nodes or a subset of interfaces. Through the modular operation at the Yang data consumer, I know then basically that I only need to consume from these partitions. Taking that end-to-end into account, basically the 2 optimization we are bringing in is through so-called topic compaction. So we are using the message key to compact the topic. We can compact to the current state for state metrics. And through the modular operation and also through the topic naming, we are now able to subscribe exactly what we want and only obtain the data which is relevant to us. Talking about use cases, so the network engineer with doing a SQL command and just getting the right data back. Same would apply also for network controllers, for instance, or for instance, network management system or network anomaly detection systems who wants to subscribe specifically, for instance, to state metrics, or an example also in section 3.2 in the CMAP concept, when we want inventory information and map then in CMAP. So to conclude here, we have 3 documents. We have the message broker architecture, the schema between the Yang data producer and consumer, and the message key document, which is describing how to index those data efficiently. So now we have 2 questions. In the network digital twin architecture, in section 6, it states large-scale challenge. A digital twin of large-scale networks will significantly increase the complexity of data acquisition and storage and the design and implementation of relevant models. The authors would like to hear from NMRG worker group whether the proposed solution, which I was just showing before, addresses this concern or not. The second question, which is very much related, is in section 9.1. It describes that there are several network telemetry data collection modes, but however, it fails to describe the data mesh integration, how the data should be organized and maintained for a digital twin architecture. Therefore, we believe this section should be rewritten and the Yang push to message broker integration architecture should be as described as one possible solution, how network telemetry data collection should be collected and maintained for the digital twin architecture. Any comments or feedback? Does that make sense what I'm describing here?
Any comments?
I see Cheng.
Cheng,
hi, Chair.
Yes, hello.
Thanks for the presenter. Thanks for your mention the question we brought in the NDT architecture. Actually, we have addressed some of the solution, and we have proposed an individual draft in NMRG group named the data collection method. If you are interested, you can check it. And we have also published another individual draft related to data named data generation and optimization for network digital twin. We are trying to use some data-oriented method and using AI or LM to generate and optimize data to somehow fix the issue or meet the challenge of complexity of large-scale data challenge. Thank you.
So maybe here one question, Cheng, and if I'm not sure whether I understood here. So at the moment, the document focuses very much on the data collection, but not how the data should be integrated in big data, how it should be organized and maintained. What you just described, is that addressing that, or does that leave that open?
Okay, good question. Yes, you are correct. Collection is just a step one. Yes, for a complete data service, we need to storage, process, and process and optimization. We believe that we have a long way to go further. Thank you.
Sure. It would be great to review what you're proposing and see whether what you're proposing and what we are proposing, whether this is aligned or what are the differences in between. Thanks.
Thank you.
And yes, Jérôme.
Okay, Jérôme.
Yeah, just quick comment on the question you have. Just as also more external point of view as well. is just looking like that, I would say that possibly it gives some answer, a possible solution for the problems that I mentioned. But as you know, this is which is more about concept, just provides problem that we want to address. But I think it's very hard to give a definite answer to which extent it will completely address the problem, depending on the digital twin and the implementation of the digital twin you have. But I would say in general, in my opinion, it gives one of the solutions to collect more data in a scalable way.
Right.
Just one way to do it.
My suggestion is that maybe the architecture document goes more away from describing solution and more towards requirements. And then basically our documents, we could see whether those requirements are being fulfilled or not, or what things are missing.
So regarding yes, about the more requirement descriptions. So as we stated, I think it was in last IETF. So for this network digital twins that has been, I think, discussed a lot, there will be another last call. So of course you are very welcome to provide input at that time as well. And it's always good to make progress in the document as well.
Okay, thank you.
More questions? Okay, so just you know, we're just trying to finish on time.
No, I was not using it because then you say more questions right now.
Yeah.
A couple of things on this. If I understood Cheng well, he was mentioning something that has to do with how you attest the different nodes in a path, and so how you can put trustworthiness on what is coming from. Fine. I offer as well what we are doing with the provenance signatures, etc. That's something we have to discuss. I guess that probably you're right that the digital twin architecture doesn't go into the details about the data integration, etc. And probably will be an interesting work to consider this. We have been making with Nacho, that you know is not here because he, again, he's enjoying his first girl, who is 1 month and a half. And we have made some works about precisely how to model the network and the digital twin so you can guarantee certain equivalence in terms of semantics and things like that. And we could explore this idea of the data flow. So it's something I like very much. So we had to talk about that. Sure. You know, I think it is worth considering, because that's one of the core aspects in the digital twins. And it's true that the architecture is a general framework that doesn't go into those details.
Exactly, and we think basically it's important to go beyond the modeling. We need to make sure that based on the models, we can actually index and make the data available in a very efficient way, right? Yeah. Because that's the challenge, is also the digital twin architecture describes, and hopefully we can address and resolve.
Definitely.
Okay, thanks.
Okay, thanks. I think that's it. We finish the session, and thanks for the presenters and the attendees, and see you in Shenzhen. Bye.